Hey everybody, today we're going to go over how to evaluate functions. Should be a pretty simple lesson. It's very similar to substituting for algebraic expressions. All right, so let's get started. Let's just kind of start with some basic review here. F of x is a synonym for the y, basically the output, the dependent value. This right here is read as the function of x. F is the notation of the function, not the variable. All right, these first couple examples here, we just have to rewrite using function notation. This is a pretty simple task. All you have to do is just replace the y with f of x. So f of x equals 6x. The function of x equals 6x. Right here, 7 plus x squared equals f of x. So the function of x is another way to just denote the letter y. All right, now let's get into what is basically new, and you will find this probably pretty easy. What you're going to do is you're going to evaluate functions, and the type of notation that you're going to see with evaluating functions is it'll say find the function of 3 or the f function of 3. So what you're going to do is you're going to take what it says. Usually that's denoted by like f of x or something like that, but it says f of 3. So what you're going to do is you're going to take that 3 and you're going to substitute it in for x. So the function of 3 is going to equal 18 divided by 3 plus 3. And then 18 plus 3 plus 3 is 6. 18 divided by 6 is 3. So there it is. So your function of 3, your f function of 3, is equal to 3. I know that seems kind of weird, but that's it. That's all there is to that one. Same thing right here. What we're going to do is we're going to take, it says find the f function of negative 4 when f of x equals negative x squared plus 9. Now we're going to take the negative 4 and we're going to place it where the x is. Now notice we're only substituting the x value. We're not substituting for the minus sign that's out there. We're not substituting for the squared. We're just putting in a new value for the x. So what I want to do is I want to be really careful, especially because this involves a negative. I'm going to be really careful about how I insert that. So I'm going to put parentheses instead of an x, and everything else is outside of the parentheses. So we're going to put the negative 4 in for x, and then I'm going to follow a good order of operations here, which means I better do exponents first. Well, negative 4 squared is positive 16, and then drop down that negative. That negative is not affected. This negative right here is not affected by that squared, so that just attaches itself to 16. So it's negative 16 plus 9. So negative 16 plus 9 is going to be negative 7. So there you have it. So the f of negative 4 is negative 7. It just means like when the independent value of the function is negative 4, the x, the dependent value is going to be negative 7. Okay, so we're just going to kind of go through some of these. Now you'll notice on these examples right here, there might be a different letter that's in front of the function that we have to evaluate. And that just means that we're going to pay attention to those particular functions. So this right here, that's the f function. This is the g function because there's a g here, obviously. This is the h, and I think you guys get the idea. So you've got different functions denoted by different letters that are in front of the x. So for this particular one, we're going to insert the 8 into the g function. So when we find the g of 8, we're going to put in negative 3 times x minus 1, and in place of x, we're going to put 8. So negative 3 times 8 is negative 24. Negative 24 minus 1 is negative 25. So the g of 8 is going to be negative 25. All right, for this next one right here, we're going to use the f function because we have an f there. And what we're going to do is we're going to put in a 9 into that f function. So the f function is going to be f of x equals negative x squared plus 7. And in place of the x, we're going to put a 9. Now, the thing that I want to kind of just make a point of showing here is that the negative sign was inside the parentheses, so I want to kind of honor that when I'm evaluating it as well. So negative 9 squared is 81. And then 81 plus 7 is going to be 88. So there you go. So the f of 9 equals 88. See how easy this is? Let's keep going though. Let's make sure we touch all the bases here. Now the next function is we're looking at the h. So the h function is negative 12 over x. I mean, the negative is right there in line with the vinculum, but really you can, I think I've taught you that like it's sometimes just better to think of that negative being in the numerator. So this time we're going to put 0 where there's an x. So put that 0 there. So this is super simple. So negative 12 over 0. And what is that? Is that 0? Is that 0? I don't think so, right? We know better than that. That's actually undefined. All right, so the function, I should say, the function of 0 does not have a solution. When the independent value is 0, there's no defined output for that x value. That sometimes happens. Right, now this one's probably a little bit kind of different, but really we're going to do the same things we have been doing, which is inserting those the independent values in for x. So the j function is j of x equals 2x plus 9. So j of x equals 2x plus 9. And this time around, when I put in for x, I'm not putting in just a single term. I'm not putting in 0. I'm not putting in 4 or negative 8. I'm putting in an expression, which is 5x plus 7. And then our job for this one is just to basically kind of clean it up and get it into simplest form. So we're going to distribute the 2 into the 5x and the 7. So 2 times 5x is 10x. 2 times 7 is 14. 14 plus 9. And then you got 10x plus 23. And that's all we can do with that one. So this particular problem right here, the j function of 5x plus 7 is going to equal 10x plus 23. I know that looks like a whole different problem, and it kind of is, but that's all we had to do. This was a little bit more abstract in terms of the algebra that was involved with it, but that is it. Okay, so that was your lesson, everybody. Tomorrow, which is Tuesday, we're going to have a quiz. So this is the last thing we're going to have. This is the last thing we're going to do before the next quiz. And we're going to keep going with functions. We're not finished, but I thought it would be a good time to stop and have a quiz before Wednesday. So everyone have a great day. Stay safe, stay healthy, and make sure you're being nice to your parents and all that stuff. All right, take care.